Welcome to today's video on how to properly use a Rust OpenTelemetry tracer layer. As developers, we're constantly striving to create more efficient and reliable software systems. One crucial aspect of achieving this goal is effective instrumentation and observability. OpenTelemetry is an emerging standard in the world of distributed tracing and monitoring, allowing us to gain valuable insights into our application's behavior. In Rust, a popular systems programming language, using OpenTelemetry can be a game changer for optimizing performance and debugging issues. However, getting started with OpenTelemetry tracers and layers can be daunting, especially for those new to the ecosystem. In this video, we'll break down the key concepts, explain how to properly use a Rust OpenTelemetry tracer layer, and provide you with practical knowledge to enhance your application's observability. So let's dive into the world of OpenTelemetry tracers and layers in Rust. To begin with, it's essential to understand what these components are and how they fit into the broader picture. A tracer is responsible for creating and managing spans, which represent a single operation or a set of operations within your application. Think of spans as a way to track the execution flow of your code. A layer, on the other hand, provides a way to compose multiple tracers together, allowing you to create a hierarchy of instrumentation. When working with OpenTelemetry and Rust, you'll typically start by creating a tracer provider, which is essentially a factory for creating tracers. You can then use this provider to create one or more tracers, each configured with its own set of properties and span processors. Now, here's where things get interesting. Layers come into play when you need to combine multiple tracers or instrumentation sources. By stacking layers on top of each other, you can create a flexible and modular system for observing your application's behavior. For instance, imagine having one layer dedicated to logging spans. As they're created, another layer that exports these spans to a distributed tracing backend, and yet another layer that samples a subset of these spans for performance optimization. By combining these layers, you can build a powerful observability pipeline tailored to your specific use case. So, what are the essential points to take away from this discussion? 1. Understand the basics. Tracers create and manage spans, while layers provide a way to compose multiple tracers together. 2. Use tracer providers. Create a provider to manage one or more tracers with their own configurations. 3. Combine layers for flexibility. Stack layers on top of each other to build a modular observability pipeline. That's it for today's video on using OpenTelemetry tracers and layers in Rust. We hope this explanation has provided you with a solid foundation for implementing effective instrumentation and observability in your own application. If you have any questions or topics you'd like us to cover next, please leave them in the comments below. Don't forget to like this video if it helped, and consider subscribing for more content on software development, Rust programming, and OpenTelemetry. Until next time, happy coding!